All right, today we're going to crack open the toolbox of the financial engineer. It's one of the most misunderstood and honestly, one of the most powerful roles in all of modern finance. We're going to see how these master craftsmen take just messy raw data and turn it into solutions that can literally move markets.
And you know, the stakes in this game are incredibly high. This quote, man, it just cuts right to the heart of the matter. Think about it. Zillow, the real estate giant, had an absolute ocean of data on the housing market, and yet their fancy home buying algorithm led to a massive, massive financial loss. It's such a powerful reminder that just having data, well, it isn't a magic wand, not by a long shot.
So that leads us to the big question, right? If having tons of data isn't enough, then what is? Well, the answer isn't just in the data itself. It's in the craftsman, the financial engineer, who knows exactly which tools to pick, how to prepare the raw materials, and ultimately how to build something that's actually robust.
You know, the very first job of any craftsman is to get the materials ready. And in finance, our raw material is data. And let me tell you, real-world data is almost never perfect. It's messy, it's got gaps, it's full of noise. You just can't build anything reliable on a shaky foundation like that.
So this first step is really just a huge cleanup job. We're trying to turn that gappy, noisy data into something that's complete and actually ready for analysis. Engineers use all kinds of techniques, like imputation, which is a smart way of filling in missing values, and outlier detection, which gets rid of those really bizarre data points that could throw the whole model off. It's really all about turning chaos into order before you can even think about building anything.
Okay, so now that our data is clean, the real construction can finally begin. Let's head over to the Forge and see how we actually build these predictive models. The goal here really is to find the hidden signals inside all that noise, the patterns that can actually tell us something useful about what's coming next. And you know, a perfect illustration of this comes not from Wall Street, but from a baseball diamond. The whole Moneyball story is just a fantastic, real-world example of finding incredible value where nobody else was even looking. For decades, baseball scouts were focused on all the obvious stuff, like home runs. But the data showed a hidden truth. The real driver of winning games wasn't flashy power hitting. It was a player's simple ability to just get on base. And why? Well, because it correlated way more directly with the actual goal, scoring runs. You can't score if you're not on base, right? So in financial engineering, this whole process has a name. It's called feature extraction. It's the art of finding those on-base percentage metrics hidden inside all that financial data. It's about looking past the obvious stuff to find the hidden variables that are the real predictors of what the market's going to do. This right here is the absolute core of good modeling.
And engineers build all sorts of models for this. They'll use regression if they want to predict a specific number, like what a stock price will be tomorrow. Or they'll use classification, which decides on a category, like a simple buy or sell signal. They also run these incredibly complex simulations to stress test their ideas and use change detection models to get an early warning when a market trend looks like it's about to break.
But here's the thing. Building a model is really just the beginning of the journey. The difference between a good model and a great one, or maybe a profitable model and a disastrous one, it all comes down to this relentless process of testing and refining.
This is where that meticulous engineering mindset really shines. They get into what's called the optimization loop. They'll build a model, test it, and then carefully tweak its parameters to get rid of any error. And then they do it again, and again, and again. They are just relentlessly hunting for the most robust settings that'll actually hold up in the real world.
And hey, don't just take my word for it. The legendary quant Peter Carr actually identified this exact skill, the ability to calibrate and optimize, as the single most sought-after talent in the entire industry. It's what separates the amateurs from the pros. So we've seen the tools in the toolbox, but what about the craftsman himself? What does it actually take to become a financial engineer? Well, it really all rests on three core pillars, a foundation of essential skills.
The first pillar of this craft is math. It's the language of logic. It's the blueprint that allows an engineer to think with absolute rigor about how these super complex systems actually work.
But a blueprint by itself isn't enough. So the second pillar is modeling. This is the art and science of using statistics and machine learning to translate that mathematical theory into a working predictive tool.
And that brings us to our third and final pillar, code. Because let's be honest, a brilliant model that only exists on a whiteboard is pretty useless. Computation is what takes these abstract ideas and forges them into practical, real-world software.
So when you put them all together, you really start to see the full picture. It's kind of like a stool with 3 legs. You need that deep understanding that comes from math, the predictive power of modeling, and the practical implementation of code. If any one of those legs is weak, the whole thing is unstable. It just won't work.
But here's the thing. Even with a perfect technical foundation, something is still missing. The absolute best engineers don't just have skills, they have a specific mindset. They think differently.
And it turns out, all those technical skills we just talked about, that's only about half the story. A deep focus on the financial problem you're trying to solve, the ability to communicate these complex ideas, and just sharp critical thinking, that's what completes the picture. It's about applying the tools with both purpose and wisdom.
So yeah, the financial engineer's toolbox is absolutely filled with these incredibly powerful and complex instruments. Everything from data filters to sophisticated machine learning models. They let us find signals in a world that is just full of noise.
And this brings us right back to Zillow, right back to where we started. The tools can fail, the models can be wrong. Which really leaves us with a final thought. Perhaps the most valuable tool in the entire engineer's kit isn't math or code at all, but the human judgment to know when it's time to question everything.